Yeah, thanks everyone for coming today, and I'll try to give a little bit of an introduction into what we tried to achieve and what we achieved in our work package on the economic assessment. If we just go to the first slide, should I? Yeah. So some of this will cross over what we've already discussed this morning. But when we're looking at the economic sustainability and when we're really thinking about prospective technologies, what we started off in the economic assessment was basically trying to make a straight out division between what we have as process innovations and what we have as product innovations. And this is what we try to carry through all our analysis and what it links into how we are basically say producing electricity in a better, more environmentally friendly way, or are we creating completely new novel products that we can then assess in a common framework. Now, below these types of innovations, what we basically considered as the kind of main drivers is the cost of producing a functional unit, just like we are familiar with in any life cycle costing tool. What we also were very interested in is the diffusion and the uptake of a product within the economy. And this is where we really made the link to the macroeconomic modeling. So this is where we see it's not just a kind of a functional unit approach, but it's seeing how a product is being used by other sectors or consumers in the economy. And the third aspect that we tried to cover in this work package is basically the concepts of risk and uncertainty and how we can embody this, because it's very relevant for prospective technologies. And based on this is that we tried to basically include this in a common framework to give us the measure of economic impact. So perhaps it's a little bit simplistic to say, but in life cycle sustainability assessment, the state of the art is very much focused on using life cycle costing to represent economic impacts in the LCA framework. So our basic starting point was, and this is obviously written in the description of work, is this all that we want to consider, or should we actually think of cost as basically one of the drivers of more broader macroeconomic impacts? So in this project we really focus on, there was a section that developed a very interesting costing tool, but the uptake of that in the broader economy. Next slide. So you've also seen a lot about the indicators this morning, and Mark mentioned this. What we basically try to do in the economic assessment is think about the kind of micro type indicators or the technology specific indicators, the costs, the capital, operational, end of life costs, the actual financial risk, the labour compensation, so the cost of labour, the import dependencies along the supply chain, these type of indicators. But then we're also interested in structural indicators, so looking at if we're seeing shifts in the economy from a resource-based economy to a service-based economy. We're looking at some of these classic economic indicators of forward linkages and backward linkages. This is basically saying how important or kind of circular and ingrained a technology is in the economy. And then the kind of more headline type indicators of the capital, labour, resource productivities, the novelty of a product, and then we did a calculation to see the impact on GDP. So the actual headline GDP was used for the impact on prosperity. The framework that we used, so we basically, this project, another project, and a third project were we had some harmonization on some of the data and the methods, and that's kind of resulted in this themes modeling framework and database. And that is a hybrid integrated input-output lifecycle assessment model. So there's a few nice terms for you there. So maybe different people will get different parts of this, but I'll go into a little bit more detail on that in a few slides. The important bit is that we capture the technological detail through the lifecycle costing and link that directly, and we capture the downstream usage or the uptake of a product and the distinction between product and process innovations there. And then we link these two to the macroeconomic framework. So this is maybe a kind of schematic of this. is the life cycle costing is almost a starting point in our assessment. This gives us information for the diffusion, the market penetration. This goes into our hybridized model, and from that model, we can basically calculate those indicators that I presented earlier. So we use an input-output modeling framework, which is a kind of generic term, but actually it has a very precise meaning, which is an input-output system is used in the system of national accounts for a lot of economic modeling. It's the basis of a lot of dynamic modeling as well, and CGE modeling. But the basic input-output model is a static model. It has the benefit that it ensures a life cycle perspective. So it's static, counterfactual. So for this study here, we basically create a representation of the economy with a prospective technology, and a representation of the economy without a prospective technology or with a reference technology there. And then the input-output also has because we have the full concept of scale, there's the optional inclusion of rebound effects in that framework. A second important piece of work that we did in the work package was to look at the future, because what we set out to do was basically make this assessment not for what it was in 2000 or maybe even 2010, but to do the assessment as with as much reasonable foresight as we could gather into what the economy would be like in 2030. So we didn't want to basically endogenize the growth of the economy based on the prospective technology, but what we wanted to do was basically, knowing that we have certain kind of pathways for development that are probably going to occur, we should do our assessment against a range of these different scenarios. So we developed some scenarios we kind of had 3 benchmark years. We had the time series, but we had a benchmark for 2010, 2030, and 2050. We basically, a lot of the kind of parameters that we included were consistent with the IEA scenarios. We chose the IEA because they were kind of, I guess, most relevant for a lot of the questions that we were looking at here. And in the scenarios, we basically capture the effects of changing of the development in different regions in the world, the different trade flows and the like, plus the efficiency changes. So as we expect the electricity sector to get much more efficient over the next 20, 30 years, as we embody that in the model, and then the impact of some of the expected demands on especially energy prices over the next 20 to 30 years. I don't know if I actually had it in the slide, but the other point is that it's a multi-regional framework. So it's actually a global model. So we capture all as I mentioned, the trade here. So we operate mainly on 9 regions around the world. So we have EU as a single region and 8 other regions in the world. So basically we have the model set up to be able to work on at that level of detail. So which gives us a reasonable insight and into where the kind of major differences in production occurs in the globe. Just to kind of flatten this out into a 2-dimensional picture, and maybe this is a bit too small and a little bit too complex for here, but I thought it would just kind of give you a little bit of an idea of like a flat picture of the framework. What we tried to do essentially was basically have life cycle inventories, but in monetary terms, as foreground processes. So we represent our technology, our perspective and our reference technologies as unit processes in the economy. And what we do is we might have a bunch of different processes that require certain amounts from other processes, but we also have the inputs from the background economy, so the costs of resources, the costs of services and the like, plus we have the costs of labour, taxes that are applied and the like, and the value added. So this is basically what we create in each of the case studies. Work is focused on that. What we provide in the background is the multi-regional input-output model, which is basically exactly the same thing. The intermediate flows of goods and services, the flows of goods and services to final consumers, the value added, and other potential extractions from society or nature. maybe the next slide actually. The other point here is basically the look of the, to capture the take-up of the technology in the economy, we have the sales of the functional units to both intermediate production here and to the final consumers here. So basically the fusion modeling and the like would tell us just the scale of the uptake of the products here. And obviously we need to kind of make sure that we're not double counting things and the like. Yeah. That's the kind of short snapshot of the modeling framework that we implemented. As I say, it's multi-regional and it's scenarios into the future. So I think I'm out of time. Just to wrap up the outcomes, is that we basically were able to create an integrated, economically balanced modeling framework, including scenarios as part of this work package. The approach that we took was to try and give a full harmonization of life cycle costing with a macroeconomic model. And one kind of benefit of this, which was a little bit mentioned this morning, is that labour is obviously an input into the economy that we describe quite well in the input-output modelling. One, we have labour described there. Any employment-related effects can easily be calculated. So for the social impact, when we looked at occupational type issues, it was actually very useful to use this. But I think, yep, that was my last point. So I think I'm out of time. So thank you very much.
Thank you, Richard. Before you leave, thank you for giving us this overview. There is still time, not for discussion, because we will do that afterwards. But there is room for one or two questions for clarification.
I'll ask one.
You will be second.
Paolo Mazzoni. Thank you very much for your presentation. Just a quick question. How much is the resolution in terms of sectors of the economy that are in the model?
Sure. It's is this working? Okay. No. It's 138 sectors of the economy. So quite a lot of detail on environmentally relevant sectors. It came from the Exciapol project, which I don't know if any work heard of, but the focus there was really kind of getting some detail into agricultural, mining, electricity sectors and some of the metal sectors. So it's kind of already set up a little bit for some of the life cycle relevant modelling.
Testing? No? Okay. I'll ask her. I've changed.
Yeah, hello. Most life cycle based economic models are driven from demand. And that is why the supply side is so aggregated. And in the work that we were doing on minor metals, everything is aggregated into huge aggregations. You don't mention this problem, but how do you solve it? How do you deal with technologies that apply in a very narrowly defined sector?
Yeah. Basically, it obviously changes from case to case there. And it's not as if we as kind of methodology developers or even data providers in a sense would actually be providing very specific technology details for every technology in the economy. So the framework that we set up, it's too late to see the slide there, that basically the foreground system that we use in the model then is described in whatever detail you require by the actual user or the case study themselves. So just like in a life cycle environmental assessment, you may have 100, 200, 300 unit processes that are all very important to have separated. Is we have the same structure here so that we can basically follow all the individual, you can describe all the technologies individually in your foreground system, but that's basically for the case studies to do, or the user to do. And then you link that to the macroeconomic So once you want to lose the resolution is where you make the link to the macroeconomic model. Once you lose it, once you link, you lose the resolution. That's 100% correct. But you have as much choice as you want to keep as much. It's a hybrid model, so you know the whole point is you have the detail where you want it, and you have the kind of the complete system in the background.
I think we can also come back.